Welcome to Chemical Analysis, where chemistry meets detective work. In this topic, you'll learn how to identify exactly what a substance is made of, whether it's a pure element or a complex mixture. This is crucial in the real world, from forensic scientists testing crime scene evidence to environmental agencies checking drinking water quality. Examiners love this topic because it blends practical skills with theoretical knowledge. You'll need to recall specific color changes, calculate RF values from chromatograms, and explain the advantages of modern instrumental methods over traditional chemical tests. Let's dive in. Let's map out the core concepts. First, purity. A pure substance consists of only one element or compound and has a sharp melting point. Impurities lower the melting point and broaden the range. Formulations are mixtures designed for a purpose, like paints or medicines, with precise quantities. Chromatography separates mixtures based on different attractions to a stationary phase, paper, and a mobile phase, solvent. You'll also need to know chemical tests for common gases and ions, and finally, modern instrumental methods like flame emission spectroscopy, which offer speed, sensitivity, and accuracy. Turning to our study notes, paper chromatography separates mixtures. The stationary phase is the paper, and the mobile phase is the solvent. Substance is separate because they have different attractions to the two phases. A pure substance gives one spot, a mixture gives multiple. To identify an unknown, calculate its RF value, distance moved by the substance divided by distance moved by the solvent. Compare with known RF values under the same conditions. Remember to measure from the baseline to the center of each spot. Now let's go through the essential chemical tests. For gases, hydrogen gives a squeaky pop with a lighted splint, oxygen relights a glowing splint, carbon dioxide turns lime water milky, chlorine bleaches damp litmus paper. For metal ions, flame tests produce characteristic colors, lithium burns crimson, sodium yellow, potassium lilac, calcium brick red, and copper green. You can also use sodium hydroxide to test for metal ions. It forms colored precipitates, like blue for copper, 2, green for iron, 2, and brown for iron, 3. Let's work through a typical exam question. A student runs a chromatogram of black ink. The solvent front is 8.0 centimeters, and a dye spot is at 4.5 centimeters. Calculate RF, for 0.5 divided by 8.0 equals 0.56. To identify the dye, compare this RF with known values under identical conditions. If the ink produces multiple spots, it's a mixture. Remember to state that RF values depend on the solvent and paper used. Watch out for common mistakes. First, remember that pure in chemistry means only one element or compound, not just a natural. In RF calculations, always show your working and don't forget to measure from the baseline. For flame tests, clean the wire loop with hydrochloric acid between tests to avoid false positives. When comparing chemical tests to instrumental methods, always highlight that instrumental methods are faster, more sensitive, and more accurate, and can detect very small amounts. To wrap up, remember that pure substances have sharp melting and boiling points. Formulations are designed mixtures. Chromatography separates mixtures and RF values help identify substances. Memorize the gas tests and flame test colors. Finally, instrumental methods like flame emission spectroscopy are superior for speed, sensitivity, and accuracy. Use these key points to secure top marks in your exam.